Okay, do we know anything about what kind of triangle that we see there? Like we've been studying isosceles and equilateral. Can we assume or prove that it's either one of those kind? No. So what's the best way to do it? Just trying to solve for x first.
Do the 130.
Okay. Yeah, that's a linear pair there, so they add up to 180, which makes this angle 50. And then how about this kind right here? Those are vertical, so they're congruent. We can just copy and paste 8x plus 4. And now we have three either expressions or known angles in a triangle, so we can just add those to 180. And we'll combine the like terms. Subtract 48. Divide by 11, we'll get 12 for x. And then it also said something else, what does that notation mean? Just as a quick review. Yeah, so we'll plug this into x, and we'll get 30 degrees. How'd you do? Raise your hand if you got that. X is 12, etc. Okay, cool. All right, we're going to just jump right in from where we left off yesterday. So if you could grab this sheet, we can start annotating it a little bit more. And as you're getting that out, I'm going to remind you what we started yesterday was, it's just up there in the basket. Just one of those orange papers. Was how do we know two triangles are identical without having to measure all 6 parts, meaning 3 angles, 3 side lengths? And so these are the only 5 ways. And you should write this at the top of your page too, to prove triangle congruence. Yesterday we moved into the idea of figure congruence versus just congruent angles or congruent side lengths. I feel like we're doing well with the idea that congruent means the same. And what we've used so far is like same size, so same length if it's side lengths or same angles if it's that. And then yesterday we kind of pushed that a little bit further to figures, and we said it has to be exactly the same figure, an identical figure. So same shape, same size, same angles, same everything has to be same. And of course we're inserting that word corresponding in there, making sure to say not everything is congruent, but corresponding parts. But we didn't want to have to measure, like if we have 2 triangles, we didn't want to have to prove that all 3 angles, or technically 6 if we're proving 2 triangles, and all 6 sides are the same. That's just too much, and it's not necessary. So these 5 ways are the ways that we will be able to prove congruent triangles without having to do that, without needing all 6 measurements. Okay, so first thing on yours. Note that the top 2 have 2 sides, 2 congruent sides. And so if you're looking at a figure and you're like, hey, there's a couple of congruent sides there, I'm probably looking at those top 2. Okay? So first one, if we know that all 3 sides are congruent, the triangles are the exact same. We don't have to even worry about angles. So if all 3 sides are congruent, the triangles are congruent. And we call that side, 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 SSS. Okay, and then the important thing on the second one, we did talk about this yesterday. The angle has to be included, meaning in between the two congruent sides. And so on yours, go ahead and make this note. We have a congruent side, and then we wrap around the angle to the other congruent side. And so you can see the SAS. So order matters. It's not, do we just have two sides and an angle that are congruent, but order matters. So also make that note. And that's going to be true on the next set as well. Order matters. So two of these are at least two sides. All right, next section. Note that these each have two angles, not at least, but just two angles, and only one side. So take a look at these two. Do you see how they both have two A's and an S? And so if you don't acknowledge that order matters, you'll be like, why do we have those separate? They're the same. They both have two angles and a side. So when we get into actually writing proofs out, so we'll be writing the two-column proofs again. If you end up proving this situation where the side is trapped between two angles, but you say, oh, that's angle, angle, side, the order's wrong, and so your proof statement is wrong. So order does matter. This one, again, the side has to be trapped between two angles that are congruent. And so I want you to make that note again. So angle, and then we see the side, and then another congruent angle. So angle, side, angle. And then angle, angle, side is two angles in a row. And this is kind of interesting. I put this note, skip the included side. So if you look at the picture, we have a congruent angle, then another congruent angle, and we're kind of passing over that side, like we ignore that side. So angle, angle, and then the next side length is the one that we use as the congruent side. And order, again, matters for that. Okay, in the second figure, angle, angle, we're skipping over that piece in between this time, and then wrap around to hit the other congruent side. So just keep making that note that order matters. And I'm just going to say that one more time, that it's just because you know two angles are congruent and a side length is congruent doesn't mean that you can just pick one of these at random. It has to match the description. Note that on this one, angle, angle, side, you can reverse and say side, angle, angle. That's okay. It's the same thing if you'd rather do it that way. All right. And then next is HL. And note that it is the only one with two letters. Please write this note out to the side. It says, just because it's a right triangle doesn't necessarily mean use this. It has to be a right triangle in order to use hypotenuse leg, but it doesn't always mean that you do if it's a right triangle. Also, remind yourself that the hypotenuse is the long side opposite of the 90. So in these pictures, it's the upper right length is the hypotenuse. So technically this one has three components, just like the others do. Here's what I mean. We're only calling out the hypotenuse and a leg, but we have to know that the angle is 90. So it's kind of a version of the others with three known pieces. We just don't say the fact that it's 90 degrees. Because there isn't a hypotenuse unless it's a right triangle. We don't call anything a hypotenuse unless it's in a right triangle. Okay, so on that, if you know you're working with two right triangles, keep an eye out for the hypotenuse and the leg being congruent. Okay, also note maybe put this on there. It could be these legs also. In other words, it doesn't have to be the short leg. So it could be those legs too. But it's not leg. It's has to have the hypotenuse be one of them. You're going to see what I mean by using all of these here as we work through today. All right, and then you probably saw this note. Note that we are missing angle, meaning if we know all three angles, that is not sufficient to prove that two triangles are congruent. So you may not use angle to prove congruence. It's not sufficient. And then same with side angle. Also, if you read that backwards, it helps you remember why we're not using that one. It doesn't work, okay? So no side angle, they don't work. They don't prove. So maybe add that note. They are not sufficient to prove congruence. We're going to use CPCTC a lot, but let's come back to it after we've gotten a little bit of experience with this other stuff. So there are other words on this paper that I didn't read to you, like this box. I kind of mentioned what it says, but you should go read it on your own. Most of the rest of it I did explain. But you need to have these memorized. These 5 things, like we wrote at the top, those 5 things are the only ways to prove two triangles are congruent. So when we're asked, are the triangles congruent, or asked to prove that in an actual written out proof, those are the 5. You can't make up others, and you can't mix these up. So start working on getting those locked in and memorized. Flip the page over. At the top of this page, I want you to write this title, Tools to Help Prove Parts of Triangles are Congruent. Some of these are familiar, but there's a really important one that's new. So these are tools that will help you prove parts are congruent. Here's what I mean. Let's say I ask you to prove two triangles are congruent. Well, you need to start proving either SSS, SAS, ASA, AAS, or HL, which means you got to start proving that lengths are congruent or angles are congruent, etc. And these are the ways that you can do that if it's not just given. I'm going to come back to number 1, but definition of midpoint. We know that means that it splits a length in half, so it marks 2 congruent lengths. Well, that one's familiar. We know vertical angles. That one's very familiar. Angle bisector, we know that one. We've worked with it a fair bit. Number 3 is kind of obvious, I think, but it is one that you can use. If you're given that 2 angles are right angles, you can say right angles are congruent. Okay? Perpendicular bisector, we already studied in this unit. So remember, it splits this bottom length in half, and it also creates a 90. So that would be a good situation to keep an eye out for the HL congruence, hypotenuse leg. All right, alternate interior angles. That was from our parallel lines unit. So just maybe out to the side, let me just remind you. do this, like just sketch this. And remind yourself alternate interior angles are on opposite sides of that transversal between the two parallel lines. Okay? What's going to be a little bit challenging about these is that figure, it's a parallelogram. That figure doesn't look like parallel lines necessarily. Do you see what I mean? Like looking at this, it shows the arrows, but you may not see it as those two being alternate interior. Here's a question. Are these two alternate interior based on the diagram? In other words, could we use it there as well? No, you may not. Why? It's because these are not marked parallel. They would have to be marked with the arrows also, right? Well, 2 in this case. Okay, so we don't make assumptions. They look nice and parallel, but since it's not marked, we cannot use those. So only base your markings on things that you know for sure. If you happen to be told that FJ and GH are parallel, then sure, go ahead and use those as well. Just make sure you're basing it on givens. Okay, third angle theorem. This one is also kind of obvious. If two angles are congruent, the third one has to be. And why is that? Like, let's say I told you that angle B and C is congruent to E and F. Why does A and D have to be congruent?
So the triangle can still have 180.
Yeah, it has to, right? If we know two angles are the same, the third one has to be because all triangles add to 180. Good. All right. And then definition of segment bisector. It looks like mine got cut off here. Segment bisector. Your picture looks something like this. Let's do a little bit better job there. If you're told that something bisects a segment, remember it splits it into two congruent halves. Just don't assume both ways. So if you look at your picture, only one set of the legs are marked. This set we can't assume is also split, bisected. It might sometimes tell you that, but don't assume it. All right, and then finally go back to that top left one. This one is really important. Put a star and say something like, this is used a lot. Okay, now I realize that at least on mine, the drawing is kind of hard to read. So put an A and a B to make sure that middle segment is clear. Here's what it says. Basically, either segment or an angle is congruent to itself. That's what it says, and that makes sense. Like if I look at this pencil, I say, hey, it's congruent to itself. There's no questioning that, right? Like I'm not trying to prove it's the same as somebody else's. It's the same as itself. Same thing with your phone or your shoe or whatever. It's congruent to its own self. Here's what I want you to do, though, to make that stand out. Let's say we're trying to prove that triangle X and triangle Y are congruent to each other. Do you see those two triangles, first of all? Like the two sides of this. Okay, so as I trace triangle X, do you see I'm passing A and B right then? I just passed through it. And then as I trace triangle Y, I just passed through BA again. So I drew that line twice, it's technically. One for triangle X, once for triangle Y, but it's the same line. So it's congruent to itself. And that allows us to prove that at least one side length is congruent. Here's the notation for that. Since we can't really do, like if we just put one tick mark, it's like, well, what are you marking it congruent to? Same with 2. So we usually put the congruent mark like an X on there. It's kind of like how it looks. So you could now say in your proof, AB is congruent to BA. There's a line in both figures that's congruent. Okay, make this note as well. This is also true for angles shared by two figures. In other words, we have reflexive angles also. This is a super handy one. It comes up fairly often, and if you get in the habit of looking for it, you're guaranteed a congruent part by doing that. So this property shows up 3 more times on this page. Go find them. Let's just mark them to remind you. Anybody see them? Okay, you should see one here. So I don't know what the letters are. It looks like HJ probably. But that line is part of both triangles and is reflexive, so it's congruent to itself. Same with number 7. And same with number 8. So this is kind of a good example real quick of what we're about to do. So let's say I just hand you this figure and I say, are the two triangles congruent? In this case, I'm going to call them triangle A and triangle B. Are they congruent? So we have to note that we marked this middle line. It doesn't have letters, but this middle line is reflexive congruence, congruent to itself. We were given that the two bases are congruent, and we are told that the two 90s, they're both 90, so obviously they're congruent. So are the triangles congruent? Give me a thumbs up or down. I'll just stick it in the bin, thanks. Are the triangles congruent? Okay. Now you need to flip back and see which one of these reasons they are congruent. So yes, you're right. Which of these, though, is the reason for it? Like, which one would we say? SSS, SAS, ASA, AAS, or HL? Okay, so you look. I'll come back to this one. We all agree that A and B are congruent. Now we're just trying to figure out why. Okay, we have one. Raise your hand when you got it. There's those 5, the only 5 that we can use. Okay, 2, 3, 4. Any others? 5, okay. While you're finishing up thinking, I'm going to write the list. All right. Do we know all 3 sides are congruent? Nope, so it's not that one. Do we know 2 sides and an angle trapped between? Okay, that one looks good. Do we know 2 angles and a side trapped between? No, we only know 1 angle. So that kicks out both of the 2 angle ones, right? And then is this hypotenuse leg? No, because it is a right triangle, but we don't know the hypotenuse. Well, at least we haven't marked that it's congruent. So in this case, it's side, angle, side. And it would go like this, side, angle, and then this reflexive side in the middle. Side, angle, side. So if we were writing a proof, it would sound like this. Something about the angles being given as 90. Something about the bases being congruent. Those would be given. We would say this length is reflexive congruent, so we'd say reflexive property. And then we would say the 2 triangles are congruent by side, angle, side. Or just SAS is fine. So that gets us into how we use this stuff. We just talked about all that, that's why I'm skipping it. Let's come back to that one. All right. So this is just going to be kind of quick interactive. Just don't shout anything out. I'll just have you raise your hand. Are these congruent? That's my first question. And then by which theorem? So are they congruent? And then which theorem? So I'll let you look at all four and then we'll discuss them in maybe like 20 seconds or so. Okay, first pair so I'm calling these upper left ones the first pair. So are they congruent? All right, yes. By which theorem? Side, side, side. We're shown that all three sides are congruent. Okay, just below that. So bottom left. Are those congruent? These are not. Why not? Yeah, this is SSA. If we look in order, it goes side and then angle. Side, side, angle. Or if we go the other way, angle, side, side. But we wrote that that's not one. It's not sufficient to prove that these are congruent. Okay, upper right one. Are those congruent? Okay. By what? SAS. Yep. So SAS. And then how about this bottom one? By. Also SAS. So you can kind of note how I'm talking through it and showing you, which is go around the figure. And it's kind of a good way, especially when you're starting out. So pick one and then just work around to the other one. And you can see SAS there pretty clearly. So these are like mini proofs, right? We're not actually writing out the two columns with statements and reasons, but we are thinking through it like a proof. All right. These ones kind of help you think a little deeper. So what additional information is needed to show that these two triangles are congruent? And we're going to do it two ways. So by SAS and by side, side, side. Let's start with side, side, side. If we're going to show, like if I said write a proof and prove this by side, 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 what would you need to know? Yeah, so we would, let's be specific about our statements. Aiden, how about you help us out? Give us one, like a specific statement. Obviously, we need to know all three sides are the same, are congruent, but specifically, which sides? So which side, if I wrote AC is congruent to, what would you say? FD. Okay, I don't know if I've mentioned this before, but we can use the name to know which sides go together because sometimes it's not obvious. So A and C were the first and last letters in the first triangle. So we have to compare that to the first and last letters in the other triangle. So FD or DF, either one. Okay? So we would need to know those are congruent. And then what's our other congruent statement? BC, and which does it correspond to? EF or FE. Okay. Like that. So at some point in your written out proof, you would need a way to show those two things are true. How about for side, angle, side? We're given that BA and ED are congruent. So what would be the other thing we would need to know? Did you say DC?
AC.
Oh, okay. Yeah, AC congruent to FD. All right, good. Which version is this? It's just another, is it congruent? That's SAS, right? All right, you're starting to see it, which is cool. Are those congruent? Don't shout it out. Let's just, in 10 seconds, we'll do a thumb up or down. Lots of good markings on this. Are they congruent? Ready, set, vote. Okay, most of you are saying no. And why not? So if we pick here to start and we go around, look what we have. We have SSA or ASS. But either way, it's one that doesn't work. So even though we had lots of good markings, it wasn't in the right order. Order matters. All right. Let's do a few more of a different kind. Now, some of this got cut off, but I think there's enough to answer the question. It says an electrician installs cables from a cell phone, something, to the ground, tower maybe. To pass inspection, so both cables must be the same length. So these two cables have to be the same length. Does this meet the cable length requirement? In other words, we're asking, is this true? So you're really asking, do we have enough information to prove if each side, each triangle is congruent? Okay, so look at it as one like we just did, and then you'll be able to say if the cables are the same length or not. So I'm letting you look for a minute. You might want to use a property on the back of your paper. Okay. So hopefully you saw this. The tower has to be congruent to itself, right? It's the same tower sticking out of the ground. So are the two triangles congruent? Yes. Why? Like, which of the theorems on your paper is why? What was it? Except for I only know one side, right? I only know this. There you go, good. So angle, side, angle. And again, it just illustrates that just because it's a 90 doesn't mean we'll use HL. We have to know the hypotenuse for that. All right, how about this one? Are they congruent? And if so, which theorem? I know there's only one, but which theorem would you use on this one? Just practicing seeing it. Which one is it? Angle, side. Okay. All right, let's do a few more and then we'll stop. So just take this one down here. These are, if you just glance at them, they're obviously not triangles, but there are pieces of the figures that are triangles. That's what we're asking. So like we could say top and bottom, and then the others are pretty clear. So take 30 seconds, 45 seconds to look at all of them, and then we'll go back through and check. Actually, while you're doing that, I'll hand you out something. So top left, the very top left. What do you think? Are those congruent? So I'm just asking, are they congruent by which theorem? Yes, these are by what? ASA. Good. So angle, side, angle. Angle, side, angle. Okay, the ones just below that. Yeah, if we start, just pick an angle, maybe start here. Remember, we skip a side, and then we have another angle, and then the subsequent side. So this is yes by AAS. And again, if you read it the other way, it's SAA, which is fine. Okay, top right, which one is that? Yeah, that one's easy to spot. Okay, next one. Okay, so this one's kind of harder. That's SAS, but look on the other one. That's SSA, so this is no. They don't match, right? Okay, how about down here? Are any triangles similar in that one? Okay, we have what? SAS, SAS, so side angle side on both. I'll just say yes by SAS. So the sheet that I just handed you is basically what we've been doing on all these quick hit problems. So state which triangles are congruent and then why. So all same as like SAS, SSS, all that. So do those for tomorrow. And then we'll start using congruence a little bit to solve. And you guys have a good day. Good morning. Can you push that down for me? Thanks.
Okay.
This shit gonna be heavy as 50 seconds of the video.
Where's number 8? Well,
I'm with football now.
I'm on 2.7. It's actually good. It's actually good. It's actually so good.
Yeah.
Yeah, level 15. So I have level 16. Evo Ghost is good. Yeah, but it's a cycle. That's why it's good. It's a cycle so fast. It's I already have my ghost again.
All right, good morning. Hopefully you've started on this.